Swaminarayan. Today we continue with the GIS and Spital Data Analysis, Unit number 3, Metadata Standards. The standard for metadata is the basis for software development by standardizing the items and item descriptions. The standards enables the GIS community to speak in like terms. This has enabled the development of the cataloging and indexing tools as well as search engineers which can pose queries against the collection of the metadata. Okay. Different countries and states have created their own standards to try to simplify and clarify the information that should be recorded. The reason for so many standards is that metadata is used for the different purposes. We shall discuss the following 3 standards. Okay. Content standard for geospatial metadata. This standard was developed by Federal Geographic Data Committee of USA for spatial data, though it has been used for non-spatial data as well. In its generic form, it is fairly flexible for entering different types of data, but there are developing profiles of the STANDERDS for cadastral data, wetland, soils, reputations, etc. Doubling core metadata standard. Doubling core metadata is specifically intended to support the resource discovery. Resource discovery involves the searching, locating. That means resource discovery. That means कोई भी आपको information चाहिए, उसमें सर्च करोगे तो आपको सब डेटा मिलेगा. उसका लोकेशन कहाँ है, उसके रिलेटेड जो भी इंफॉर्मेशन है वो आपको मिलेगा. That is called the resource discovery. Involves the searching, locating, retrieving information resources on the computer-based network in response to queries of a human user. ISO standards for the metadata. Recently, the SO has developed and approved an internal metadata standard ISO. This, each nation can draft their own profile of ISO with the requirement that these include some core elements. The next one is transformation. Transformation is the process of changing the representation of a single entity or a whole set of data. In GIS, transformation may involve changing the projection of the map layers or correction of the systematic errors resulting from the digitizing. Okay, जो भी अंदर errors है उसको हम change करते हैं. Okay, उसके projection, map का जो भी projection, map layers का जो भी projection है उसमें changes करते हैं. That is called transformation. In addition, it may be necessary to convert data head as raster to vector and vice versa. In addition, to convert data, जो भी data है उसको raster में से vector में convert करना है और vector में से raster में convert करना है. That is called transformation. It is the ability of GIS to transform the spatial data, for example, from one entity type, that is point, line and areas, to another, and to perform spatial analysis that distinguishes it is from other types of transformation systems like MIS and CAD. Data derived from the maps drawn on the different projections will need to be converted to a common projection system before they can be combined or analyzed. Data derived from the maps drawn on different projections will need to be converted to a common projection. That means आपके पास एक मैप है और आपके पास 3-4 मैप है. ओके, तो वो अलग अलग डायमेंशन है, अलग अलग स्केल में है, तो उसको आप कंबाइन नहीं कर सकते. तो वो आपको एक स्केल में उसको स्केल में एक ही स्केल में उसको कन्वर्ट करना पड़ता है. ओके, तभी आप कंबाइन कर सकते हो और एनालाइज कर सकते हो. If not reprojected, data derived from a source map drawings One projection will not plot the same location as data derived from the another source map using a different projection system. तो आप देखो सेंसर भी अलग अलग यूज करते हो और देन जो भी फोटोग्राफ खींचे है उसका प्रोजेक्शन सिस्टम भी अलग अलग होता है. तो उसको फर्स्ट ऑफ ऑल एक स्केल में करना पड़ता है. आप कंबाइन कर सकते हो. फॉर एग्जांपल एक फोटोग्राफ आपके पास डिजिटल मैप है या डिजिटल इमेज है तो उसको कंबाइन करना हो तो आपको क्या करना पड़ेगा, एक स्केल में उसको एक ही स्केल में कन्वर्ट करना पड़ेगा. दैट इज कॉल्ड ट्रांसफॉर्मेशन. For example, if the cost line is digitized from a navigation chart drawn in the marketer projection, that means cylindrical, and the internal census boundaries of the country are digitized from the map drawn, the Albert's equal area projection, conic, then the census boundaries along the coast will be plotted directly on the top of the cost line. दैट मीन्स आपके अलग अलग प्रोजेक्शन सिस्टम से जो भी इमेजेस खींचे हैं तो क्या होगा, उसका शेप अलग अलग आएगा. टॉप से वो फोटोग्राफ दिखता है तो उसी तरह से उसका इमेज आएगा. इन दिस केस देयर विल बी ऑफसेट एंड विल नीड टू बी प्रोजेक्टेड इनटू द कॉमन प्रोजेक्शन सिस्टम बिफोर being combined. Data derived different sources may also be referenced using the different coordinate system. तो जो डेटा है डिफरेंट डेटा है ओके उसको कंबाइन करना है तो क्या करना पड़ेगा, different sources may also be referenced using different coordinate systems. तो उससे आप क्या कर सकते हो, जो भी डेटा है उसको डिराइव कर सकते हो. The grid system used may be different origins, different units of measurements, and different orientation. If so, it will be necessary to transfer the coordination of each of the input data sets onto a common pattern. This is quite easily done and involves a linear mathematical transformation. Some other methods commonly used are translation and scaling. One data set may be referenced in 1 meter coordinate while another is referenced in 10 meter coordinates. If a common grid system of 1 meter coordinate is required, then this is simply a case of multiplying the coordinates in the 10 meter data set by factor of 10. That means आपके पास आपने 1 मीटर कोऑर्डिनेट यूज करके आपने कॉमन ग्रिड सिस्टम का यूज करके आपने 1 मीटर कोऑर्डिनेट फिक्स की है. तो दिस इज सिंपली केस ऑफ मल्टीप्लाइंग द कोऑर्डिनेट. फॉर एग्जांपल 10 मीटर डेटा सेट का यूज करते हो तो आपको क्या किससे मल्टीप्लाई, जो भी डेटा है उसको किससे मल्टीप्लाई करना पड़ेगा, 1 डिवाइड बाय 10, दैट इज फैक्टर 10. क्रिएटिंग कॉमन ओरिजिन. Multiply the coordinates in the 10 meter data set by factor of 10. Then next, creating a common origin. If two data sets use the same coordinate resolution but do not share the same origin, then the origin of one of the data sets may be shifted in the line with the other simply by adding the difference between the two origins to its coordinates. Creating a common origin, if two data sets use the same coordinate resolution but do not share the same origin, that means दोनों के पास different origin है, then the origin of one of the data set may be shifted in the line with the other simply by adding the difference between the two origins to its coordination. And rotation. Map coordinates may be rotated using simply trigonometry to fit one and more data sets onto a grid of common boundaries. Then vectorization or R2V conversion. Vectorization refers to the conversion from the digital raster image with the digital vector data, which is often called the raster to vector conversion. Vectorization is difficult as compared to the rasterization because vector format requires, for example, direction of the line chain, boundaries and nodes of polygon, order of series of chain that form a polygon, and so on. And on screen, manual digitizing is a simple R2V conversion process. In this process, raster map images are displayed on the computer screen. These raster images are traced with the vector point and line polygon in different data analysis, different data layers. Advantages of this process are zooming facility gives the higher accuracy. Image processing techniques can be applied on the raster images to convert the errors of the enhance the image. Errors or enhance the image. Conversion process can be made faster, etc. Most of all, GIS software provides the manual conversion of the raster into vectors. Rasterization. Rasterization refers to conversion from the vector into the raster below. This technique is readily performed. Raster format is more convenient in some specific applications such as adding data into existing raster map. Raster format is more convenient in some specific applications such as adding data into the existing raster map, web application, etc. Rasterization is also useful to integrate the GIS with the remote sensing because remote sensing images are in raster format. In some cases, vector data are interpolated to create a raster. Example, creation of the digital elevation model DEM from control lines or points, which is known as a surface model. The globe, which is divided into various sectors by the lines of latitude and longitude, is a true representation of the Earth. Network of latitudes and longitudes is very practiced. A map projection denotes the preparation of the reticule of the flat surface. Map projection is defined as a systematic drawing of the parallels of the latitudes and meridians of the longitudes on the plane surface for the whole Earth or part of it on the certain scale so that any point on the Earth's surface may correspond to that on the map projection is defined as a systematic drawing of the parallels of the latitude and meridians of the longitude on a plane surface for the whole Earth or part of it on a certain scale so that any point on the Earth surface may correspond to that on the and the curved surface of the Earth is shown on a flat field. Some distortion is inevitable. On large-scale maps, the distortion caused by the map projection may be negligible because the map will typically cover only a small part of the Earth's surface. On a smaller scale, the maps such as regional maps and world maps when small distances on the map represented a large distance on the scale. This distortion will have a bigger impact. Map projection. Classification of the map projection is there are a wide range of map projections in use. Different map projections are used in the different parts of the world for mapping different sizes areas, sized areas, and for different applications. There can be as many classification as many basis table 3.3 shows the classification of the maps depending on the different bases. Map projection can be classified into the following four general classes: cylindrical map projection, conical map projection, azimuth and uh, zenithal and planar map projection, and miscellaneous. Cylindrical map projection. Cylindrical map projection result from projecting a spherical surface on a cylinder. Cylinder map projections result from projecting a spherical surface onto a cylinder. When a gradually is prepared on the surface of a hollow cylinder, it is called cylindrical purposes. In cylindrical projections, meridians are geometrically projected onto the generally projected onto mathematically projected, and this produced real angles of 90 degrees, and the cylinder is cut along any meridian produces the final cylindrical projections. The meridians are equally spaced, while the spacing between the parallel lines of the latitude include towards the pole. If cylinder is rotated and or made tangent on secant, the more complex cylindrical projections are obtained. Advantages: continuous picture of the earth. Continuous picture of the continuous picture is now usually many views of the next one is countries near the equator. That means a country is near to the equator in the true radio position. Area for the most part is preserved. Disadvantages: distances increases between the countries located towards top and bottom of the range. The view of the point is very distorted. This one is for vector calculation of cylindrical and conical. Various cases of the cylindrical and conical projections. Then conical map projections. Conical projections result from the projecting a spherical surface onto a cone. A cone may be imagined to search the globe of a convenient size along any circle. Then the most useful case is the normal cone in which the apex of the cone lies vertically above the pole on the terrain axis produced, and the surface of the cone is tangent to the sphere along some spiral of the latitude for the standard pattern. The meridians the meridians are projected onto the conical surface, meeting at the apex of the cone, while parallel lines of the latitude are projected onto the cone as strings. The cone is then cut along any meridian to produce the final conic projection, which has already converting lines for meridian and concentric circular arcs for the parallel. The meridians are projected onto this conical surface, meeting at the meridians are projected onto the conical surface, meeting at apex of the cone, while while parallel lines of the latitude are projected on the cone as string. The cone is then cut along any meridian to produce a final conic projection, which is straight and converting lines for meridians and concentric circular arcs for parallel. Map projections may scale for the most part is preserved and area is distorted. Distance is well distorted over the bottom of the image. This one is called a photograph projections. यहाँ projections आप देख सकते हैं यहाँ पर photograph projections है. Okay. Again standard parallels, meridians, and standard parallel, tangent, etc. As you make zenithal, planar, map projections, azimuthal projections result from projecting a spherical surface on the plane. In this projection, a flat paper is assumed to touch the globe at one point, and the project the lines of the latitude and longitude of the plane. The point of contact may be North Pole, South Pole, a point on the equator, or any point is between this point is the focus of the projections. Types of the zenithal projection with respect to the planes. Projection touching the globe are normal and equatorial zenithal, where the plane touches the globe at equator. Then polar potential, where the plane touches the globe at pole. Oblique zenithal, where the plane touches the globe at any other point. Types of zenithal projection according to the location of the viewpoint are genomic, central row point lies at the center of the globe. Stereoscopic viewpoint lies at the approach point. Then orthographic viewpoint lies at the infinity. Advantages and disadvantages. The disadvantage for the most part, the disadvantages is distance for the most part is preserved. Disadvantage of the part of the surface is visible, and the view will be of half the globe always. Distortion will occur at all images. This one is called map projections. Okay. Thank you.